Hi, today I would like to present to you about the design of digital blood glucose meter based on Arduino Uno. I am from group 12 and the first member is Nuraini binti Zulkarnain, Puteri Nazatul Iman binti Abdul Saad and Nur Hasha Afika binti Ahmad Jahid. For the introduction, millions of people throughout the world have been suffer from diabetes, which is a kind of metabolic disease. It is characterized by hyperglycemia resulting from defect in insulin secretion, insulin action, or both. Many methods have been used for the detection of glucose such as amperometric, spectrophotometric, fluorometric methods. Compared to conventional method, biosensor can provide improved specificity, detection limit, and speed of response. A lot of effort has to be done in exploring non-enzymatic electrochemical glucose sensor, which depend on direct oxidation of glucose by using noble and transition metals as electrocatalysts. Noble metals such as platinum, gold, and palladium have been explored in non-enzymatic glucose sensor. It is well known that noble metals are expensive. Moreover, they're being depleted in order to resolve this problem and maximize the usage of a noble metal. Novel nanoparticles with core and shell structure have been explored recently.
For my part, I will explain the project program / coding and simulation result. As you can see from the screen, the first part of the coding is to declare the potentiometer, push button and buzzer. Next, the LCD is set to display the glucose level. Each pin that related as input and output port is set based on its connection towards the Arduino Uno in Proteus. In void loop code, when button 2 is pressed, the LCD will display the potentiometer setting at line 1, column 1. Next, in the coding, when port 1 is equal to 150, the buzzer will make a sound.
This is the example for the flowchart. The first one will start the device and it will initialize all the components, and the second one is request for EGBTS and blood. At the same time, it will alert the alarm. It is to alert the patient, and it will delay of 5 seconds and accept analog voltage and perform AD conversion. The next one is it will compute glucose concentration and display the result.
Next, as you can see from the screen, I will be explaining the simulation process of our project. First, the circuit is built by referring to the project circuit diagram in the previous slide. Next, coding that was developed in using Arduino IDE is inserted into the Arduino in the Proteus before we can run the circuit. After the coding is inserted, the circuit is in the Proteus can be run. From the screen, we can see that the LCD is displaying the glucose level based on the potentiometer rotation. When the potentiometer is set to 150, supposedly the buzzer will make a sound to notify its user.
Now we go to the part project 3D prototype. While doing this part, there is some trouble with the Arduino PCB layout because it does not have in the 3D layout in the Proteus. Therefore, we need to use Arduino Nano PCB layout to replace its pins. So then our 3D diagram can be generated. That's all from us. Thank you.